Hello, everyone. So the title of this presentation is Foundry, and apparently it wasn't updated, but our main point here is that we want to secure $1 trillion on-chain with Foundry. Right now, we're not super far away. We are not like probably a few hundred billion, but for the next trillion and for the next 10 years, we're looking to use Foundry to secure the next $1 trillion on-chain. So we still see a lot of this kind of like hacks where protocols lose hundreds of thousands of dollars, millions of dollars of their users' money in what could have been a simple test written in Foundry in, as you can see here, in like 30 seconds. In this specific case, where like a condition for a only owner check was inverted by accident, and this wasn't caught by manual review, by presumably security audits of the contract, because it's such a simple mistake that is easily missable, but it's very simple to make a test case for. So we still see these kinds of hacks even today. What we're trying to aim for with Foundry is to make the experience for both the developers and the security auditors very simple and easy to catch these kinds of things by providing excellent tools, fast, efficient tools. As Georgios mentioned yesterday, the goal of Foundry is very similar to the Rust compiler's goal of empowering developers to build efficient and reliable software. So in our case, empowering developers and smart contract auditors to build efficient and reliable smart contracts. So another thing is that developers end up delegating a lot of their security measures to almost entirely to the auditors, but the auditors don't have all the time in the world. They have an allocated time slot where they try to find, well, they would like to focus on critical things such as the core logic of the protocol, but end up just a lot of time wasting time just finding these very simple and easily catchable mistakes in their code in the smart contracts that could have been easily caught with just very simple tests. And so in this screenshot, you can see that the auditors explicitly said that because we found so many bugs in this audit, it's statistically likely that there are so many more that we just either didn't have the time to or the resources to find them ourselves. So, so this is our goal with Foundry. We last presented at Frontiers 2024, where we had 400 contributors. Now we have 500. We're always growing in PRs, in contributors, in stars. Foundry is, I believe, in the last Solidity survey, was the biggest test framework that people use, with hundreds of respondents saying that they use Foundry over Hard Hat or other frameworks. So another thing we're going to highlight here is that we released 1.0, so we're committing to stable releases, and this is our release process right now. We still have our nightlies that are built every day off of the main branch, but now we have stable releases that we branch off of master every month or so. Right now, we begin with an RC. So we create a release candidate that we ask people to test using the RC version. Then we iterate over the RCs, and we eventually release a new version. And then if any bugs or regressions were found after the release, we make a patch version. So the main highlight here is that we have RCs. These might not be super easily findable, but we do ask people to test using these versions. It helps us out for feedback on new features and performance improvements, for example. Something else we do in this release process is that we now have also attestations with the releases. So Foundry app will automatically verify that the releases are correct. And alongside the hash, we also have like attestations on GitHub releases. As part of the release process, we also run benchmarks. We consider performance regressions as any other bug. So we do block releases on performance regressions. And in general, we try to have performance improvements on every release. So now we have benchmarking as part of the release process, benchmarking against previous versions. So here's the timeline since last year. We released Solar, the first version of our Solidity compiler. We released Foundry 1.0, Alloy 1.0, a bunch of Foundry versions, which we'll be talking about soon. Last main highlight is that we now have a new website. It was rewritten using Vox, which is the static documentation generator written and maintained by the WAGMI maintainers. We also have migrated the Alloy and the REST website using this new framework and a new style for our websites. So we released Solar last year in November. What is Solar? Solar is our Solidity compiler written from scratch, inspired by the Rust compiler. So the main focus of Solar is improving the developer experience of Solidity developers. As many of you know, the main bottleneck at this point in Foundry, in the Foundry development cycle, is actually just building the project instead of just running the tests. Usually, tests run faster than a clean build of the project, or even just a recompilation of the project, because and this is mainly due to Solidity, the Solidity compiler being pretty much slow. Nothing else to say there. So our main focus here is just trying to, the only path forward we saw to improve this is because Solidity compiler is kind of like a black box. We just pass it in the sources, and then we get the output back. We decided to write our own compiler from scratch with performance in mind, with modularity in mind, with extensibility in mind. So our, let's see. This is one of the benchmarks. As you can see here, Solar with thinking is way faster than Sol-C. So, OK, never mind, like, wrong one. This is the actual benchmark. So the main part that's currently done, like Solar is still work in progress, but we do have a part of a front end, and this includes the parser. So the parser is currently 5 times faster than Sol-C on average. And the ABI is 50 times, up to 50 times faster. For example, here on Sol-80, it's 1.5 seconds versus 30 milliseconds. So we use this extensively in Foundry to analyze the project, to traverse the AST for various things, including like the new forge lint, which Mark will talk about. And here's another benchmark, or OK, what else? So currently the front end is almost done. We have the compilation pipeline done up to the ABI, which is essentially just emitting the interface of your contracts, so we don't have bytecode generation, which will be our next focus, including these are some other focuses, like, for example, the middle NDIR. We want to have like a generic, abstracted intermediate representation for us to be able to support multiple backends. For example, the new Solex released by the newly released Solex compiler, which is currently just a backend, and others, for example, Venom from Viper, or even Yule. So we released Foundry 1.0. This is a few of the highlights. This is benchmarked against Foundry 0.2, which is, I think, 2 years old at this point. But obviously, we have way faster compilation, way faster tests. We added a bunch of new cheat codes, including gas snapshots, which are extensively used by a lot of people to measure the performance of the smart contracts. We have new cheat codes for symbolic execution. So, for example, you can integrate it with control. We often release support for the new hard forks way ahead of time so that people can test it. And of course, we're committing to stability and reliability for the future. In 1.1, the main thing we wanted to highlight here is that we have added support for a new configuration flag called dynamic test linking. This is also to address like the main bottleneck of compiling Solidity, where we what this does is essentially decouple sources from tests, so that when you modify a source file, the next time you recompile, you don't have to recompile the entire project. And this saves up to, this is up to 130 times faster, as you can see here from the benchmarks. In one case, from 130 seconds to 1 second. So, yeah, thank you. Some other highlights are just improved performance, UX improvements, and new ambient endpoint. ETH Simulator v1 is actually extensively used in Porto. So if you're using Porto and you're using Anvil to locally, you now have support for ETH Simulator v1, so you can use it locally. Another thing is we released is Alloy 1.0. Same thing as Foundry. We commit to like supporting and like stability and reliability for newer releases. Alloy is just a rewrite of EthRS from the ground up, re-architectured. The website is also migrated to Vox. These are a few benchmarks against EthRS: 50% faster U256, for example, and 10x faster ABI encoding thanks to the Sol macro. These are a few of the highlights. Don't have much time to go over. The main highlight here is that the Sol macro lets you write Solidity inline in your Rust project. And this also enables you to have way faster ABI encoding, decoding, and a nice high-level wrapper for the smart contract so you can use it to call functions on chain or simulate whatever. Last thing, I'm going to pass it to Mark for 1.2.
Yeah, so we have a lot of stuff to unpack. Maybe the time for Q&A will be a little bit shorter, but yeah, let's get into it. So Foundry B1.2 was like basically like an ecosystem integration release. We integrated the new Etherscan v2 API, where they unified all the endpoints, and now you have a single API key. We are still backwards compatible, but they will be deprecating like B1 soon, so we will do the same as well. Then, as Danny mentioned, like we already had early EIP 7702 support, but it was more of a like prototyping sort of support. So here we did like further releases, and we added new features, right? So that now we would have like a dedicated Anvil endpoint. We also added support in CAS, so that you could like assign and recover like auths, as well as like attach auth lists. And then we had to patch an issue that we had in Forge where nonce like management wasn't properly handled. now you can also like set empty code again if you delegate to the 0 address. And we also support like cross-chain delegation as well as like multiple delegations, because before we were limited to just one. So all this stuff, like the community kept opening like issues, and we kept like progressively iterating. Yeah, so in Foundry, V1.3, it was like this was a big release. It went live like not too long ago. This was like one of the biggest like security-focused release that we had, and I think it really sets like the tone for what's coming, right? So yeah, despite it's like highly like feature focused, as always, we focus on performance. So this is built on top of REVM 27. We also dedicated like some effort to improve the stack inspector, and this like ended up giving us like more or less 20% improvement when running like forge tests, which is pretty cool. On top of that, Matt had an idea, which is that for fork tests, when we need to get the account information before, or I mean, it's still the case, you need like 3 RPC calls. So he created a new endpoint on Reath that allows us to get all that information with a single API call. So when you are doing fork tests, if you use a Reath node, you get like up to 11% of like time savings in your tests, which is pretty cool with just like this new API endpoint. So we encourage like other clients to also integrate this endpoint, because it's pretty cool, as you can see in the benchmarks. Yeah, so as per the features, one of the highlights, or like one of the biggest things of this release is ForgeLint. So basically, with ForgeLint, we bring static analysis capabilities into Foundry, which is like super powerful. For those of you who don't know what static analysis is, it's that basically, thanks to Solr, we analyze the code, right, and we get an idea of its like semantic and capabilities, right, of the code that you've written. And then based on that, we can like identify patterns. And based on those patterns, we can flag you issues that your code has. So this is not, this doesn't require any runtime. So even before you've written any test, like you've just like write your Solidity code, we can already tell you, hey, you most likely have a bug here, or you could do this better in this way. So this is super powerful. And now we just need to keep adding lints to make it better. More on this like in the following slides. We also gave a lot of effort into improving like testing, especially invariant testing. So now we will have like coverage-guided fuzzing and time-based campaigns, as well as stable testing. I'll explain it in a couple of slides. And then other cool features that we have, highly requested by the community, especially auditors, is like better support for EIP 712 signatures and hashes. Like apparently, a lot of devs were doing mistakes when generating the hashes or when encoding their structs. So we added new cheat codes and neat commands that make it super easy. You can then verify that your code is sound. And as everything that we are doing, we are always trying to document everything. We have high standards for that. So you will find like example in the docs, and you can simply copy what we do and adapt it into your code bases. We added new albedo endpoints, so similar to how in Foundry you are used to, like in Forge, you are used to deal balances in your unit tests or like fork tests. Now you can do the same in Anvil with some MPI endpoints. So you can deal ERC20s or deal ETH approvals. And we also have support for querying blobs and sending raw transactions. And finally, this is also pretty cool. Now Foundry has like a log file, so you can pin dependencies. So yeah, for example, if you have like some Open Zeppelin dependencies, you may have a food gun if you don't pin the dependencies, because they push a lot of stuff to their main. So yeah, this is pretty cool. Gives us a lot of like peace of mind, and it's something that the EF wants to push into all the development frameworks. So pretty nice. Yeah, so for ForgeLint, I'll like explain a little bit more what it is, other than like these static analysis capabilities. Our idea when we designed it is that it's highly inspired in the Clippy experience that we get in Rust. So it's like an enhancer of your productivity and the security of your code. So it leverages Solar's AST and HIR, and especially its visitor traits. And with that, we can identify the issues, as I mentioned. And then we also use Solar's diagnostic emitter to emit these warnings. It's really easy extensible. So we build it in a way where you simply write a macro. You define your struct, you write a macro. All the boilerplate is handled by us on the background with this macro. And then you only need to implement either the early lint pass, if it's an AST-based lint, or the late lint pass. So anyone can come. You write the macro. And with the implementation of this trait is where you really focus on the security logic. You assess whether you should issue the warning or not, and that's pretty much it. From a user perspective, how it looks is that you can configure which source of lint you want. We have different severities. You can decide which files you want to be linted, which not. So it's pretty flexible. What else? Yeah. So we also issue code suggestions. And basically, when you see the lints, you will see how to fix them. And by default, it runs on build. So I will speed up because we are over time. There's sorry, we will be a little bit late, but I will try to enroll. So basically, we have some cool PRs that you can easily create lints with Cloud Code. So please check that out. We will help you. Here are some examples. Pretty cool that it's not only security-based, so we can also help you if you face something like code size limits, right? You may not know it as a developer, but you can use some tricks like reducing your modifiers, and this is a lot of stuff that we can flag. This one is coming soon as well, so we will have gas savings. You will be able to have your small vectorized optimizer, and we will prompt you to do some inline assembly to improve stuff and make it more efficient. Then for invariant testing, basically we implemented this coverage guided fuzzing. For those who don't know what invariant tests are, is that basically we chain a lot of calls across your contract with different patterns and also with different call data, and we hope to break the invariants that you defined. So coverage-guided fuzzing is a smart way to do that. We maintain a corpus, which basically is the state of each of these calls, and then based on the calls that look promising or the sequence of calls that look promising, we can find new paths and hopefully unfold a path that breaks the invariance. We support different strategies, and we can add more in the future. Time-based campaigns means that you are not limited anymore by the amount of rounds. Now you can say, I want this invariant to run for, I don't know, 2 days. So you leave it running in your server, and then you can come back and see the findings, which is pretty cool. And you have a nice progress bar indicator. We also added table testing, which basically is something the community requested. The idea is you define a test case, input and output. With a forge fixture, you can define all the different test cases of the table, and then you write test, the name of the fixture, in this case sum, and you simply assert it. We have examples in the docs. So yeah. Wrapping up, I have just a couple of slides left. What's next? So we explained a lot of stuff, but we are sorry, but yeah, we are gonna unpack everything that we have. So for what's next, super important, the Solar rollout. So as you've seen, every time that there's a sun means that this was powered by Solar, and there's a lot more stuff that it unlocks. For example, we are working on a faster formatter. We will have more powerful lints. So eventually with Solar, as we keep improving it, we will have a control flow graph. And this will allow us, for example, to detect reentrancy, which is not possible yet with forged lint, but it will be down the line. So the idea is that thanks to Solar and thanks to stuff like ForgeLint, we will be able to raise the floor of security that devs offer. Right now, or until now, Foundry has been a lot about raising the ceiling where we offer all these like invariant testing like fuzzers. But if people don't use it, like we cannot benefit from that. Thanks to these features, we bring the security to the devs, and that's pretty cool. There's also like an open PR to implement an LSP. This is also possible thanks to Solar. Pretty cool. We will probably help there. There's one PR which is like close to being ready, which is like mutation testing. It's been done by these guys, like the Wonderland. Pretty cool. Also, before I forgot to say it, but it was on the slides. Like, shout out to Alpha Raj, who's been the guy like carrying all the invariant testing. That's like super cool, and he's been helping a lot. Same here. Like, we love community like contributions. And basically, what mutation testing is that you may write tests, but with like the fact that you pass a test doesn't mean that your test is safe, right? So with mutation testing, what we do is like we flip the conditions. For example, if you have minus or equal than something, we will mutate this, convert it into just a minus, and then we can rerun the test and see which tests survive and identify like weak spots on your code, like tests that need hardening and stuff like that. So it's pretty cool to find edge cases that otherwise would be missed. And yeah, we will continue improving the fuzzer. So everything that I explained, it's just for invariant tests. We are bringing this also to the like regular fuzz test. We will remove the prop test dependency, which right now makes us execute everything like single-threaded, and we will basically run it in parallel. So your test will run like way faster. We will also have like the ability to drop tests once we find a failing test, because right now, because of prop test, we need to wait until the execution finishes. But with a flag, we will be able to drop tests early, which is pretty cool. And finally, we will have like an AST-seeded dictionary, which means that rather than starting with an empty dictionary and not knowing anything, basically, we will be able to pull in values that we think are interesting that can allow us to find like breaking test cases beforehand. Then we have also like the Anvil integration for Wreath. So I don't know if people know it, but like Anvil is a standalone node, and this means that there's like a lot of development effort by our engineers in maintaining like Anvil, right? This doesn't make much sense because we have a team, like an excellent team who's doing Wreath. They built a great SDK, and yeah, the idea is to do the work just once and benefit from that. So once we integrate Anvil with Wreath, we will have like production performance sort of for free locally. We will have all the extensibility and composability, and the main benefit is like custom precompiles, which is something that people really, really ask. And last but not least, we also want to solve like multi-chain pain points. We are aware of that. We are working on those. And basically, we need to improve the verification workflow. We know it's tedious to like run it for all the block explorers. We know that it's tedious to run it like for all the chains. And also, we know that devs right now are doing trickery with FFI and like JSON files to import variables on their setups for multi-chain scripts. So basically, we will work, or we started to work already in improving all of that, which is pretty cool, and it should help you like have safer deployments, which in the end is like what we all want. So yeah, that's it for the talk. I just want to say thanks to all the contributors. Like Foundry wouldn't be here without all of that. We encourage people a lot, please, to use the release candidates. This will help us like not move things to stable until they are safe. And any contribution is welcome, even if it's like docs, PRs for feature requests, for issues. Like anything that you can do is super welcome, and we encourage you to do it. So I don't know if we have time for QA, but we can try it. Thanks, guys.